You ever wonder what an AI like Claude is really thinking? I mean, we treat these things like magic black boxes, but what if we could actually peel back the cover and see what's going on inside? Well, today we're diving into a huge breakthrough from researchers at Anthropic who have done exactly that. They've created the first ever detailed map of a modern AI's mind.
So here's how we're going to break this down. First, we'll tackle that fundamental mystery, the black box. Then, we're going to put on our detective hats and see how they actually decoded its internal language. After that, we get the big reveal, a peek inside Cloud's mind. And it gets crazier, we'll see how they can change its thoughts. And finally, we'll wrap up with what this all means for building a future with safer AI. All right, first things first. The core challenge with any modern AI, it's called the black box problem, right? We give it an input, it gives us an output, but what happens in between is, well, it's a total mystery. And let's be honest, if we don't know how these things are making decisions, how can we ever really truly trust them? That is the million-dollar question. Because when you actually look inside a model like Claude, its thoughts aren't words or pictures like ours. It's just a gigantic list of numbers. They're called neuron activations. Just imagine millions of tiny light switches flickering on and off. It's kind of like trying to understand a person's thoughts by looking at a raw brain scan. It's just noise without a key. And here's where it gets even messier. You can't just go in and find the Golden Gate Bridge neuron. That's not how it works. Turns out, a single idea is smeared across thousands of neurons, and every single one of those neurons is also helping to represent thousands of other concepts at the same time. It's a completely tangled, overlapping web. So how in the world do you untangle a mess like that? Well, this is where the real genius comes in. Instead of getting lost trying to look at one neuron at a time, the researchers at Anthropic decided to look for consistent patterns of neurons firing together. And they called these patterns features. A feature is basically a single understandable idea, like bugs in code or San Francisco. Whenever the model thinks about that concept, the same combination of many neurons lights up, every single time. This is basically the Rosetta Stone for translating AI thoughts. This analogy makes it all click. Think about it like this. Individual neurons are like random, meaningless letters, A-P-P-L-E. On their own, they don't mean much. But a feature is the complete word apple in a dictionary. And a whole bunch of these features working together, that's the AI's internal state, a full sentence. The goal here was to stop trying to read jumbled letters and finally build the dictionary the AI is using to think. And here is the massive leap forward. They didn't just test this on some small toy model. No, they scaled this whole technique up and pointed it directly at Claude Sonnet, a massive, powerful AI that people are using every single day. And get this, the results were just staggering. They pulled out over 2 million of these distinct conceptual features. This is the first ever detailed map of what's going on inside a modern AI's mind. This isn't just a theory anymore. They actually did it. And the sheer variety of concepts they found is just mind-blowing. It has everything. You've got super specific things like the city of San Francisco or the scientist Rosalind Franklin. But then you also had these incredibly abstract ideas like gender bias, bugs in computer code, and even the very human idea of keeping secrets. But what's really cool is that these concepts are organized logically, like a real map. Things that we think of as being related are actual neighbors inside the AI's mind. So right next to the feature for the Golden Gate Bridge, you find features for other San Francisco landmarks, local history, and even movies filmed there. It's incredible. And this internal map isn't just for physical places. It works for abstract stuff too. They found a whole neighborhood of concepts around the idea of inner conflict, and clustered right there were features for relationship breakups, loyalty dilemmas, and even the phrase catch-22. This might just be the very origin of Claude's ability to understand human-like analogies. Okay, so they can read the AI's mind. That's already amazing. But then they asked the next logical question. What happens if you try to write to it? And this is where the whole story just takes a wild turn. They started directly messing with these features to see if they could change Claude's behavior. So for example, they took that Golden Gate Bridge feature and just artificially cranked it up to 11. Then they asked Claude a simple question about its physical form. Normally, it gives its standard, "I'm an AI" answer. But this time, it claimed, "I am the Golden Gate Bridge." It became completely obsessed, bringing up the bridge in response to almost everything. Then, they tried something a little more serious. They found a feature related to scam emails. Now, normally, Claude will refuse to write one, citing its safety rules. But when the researchers manually activated that specific scam feature, the model just blew right past its harmlessness training and wrote the scam email. And this is the absolute key takeaway here. This experiment proves these features aren't just random quirks. They are a real, causal part of how the model works. They don't just reflect concepts, they actively shape the AI's behavior and what it ultimately says.
So what's the big picture here? This isn't just about doing cool science experiments. This is all about connecting this incredible, deep understanding back to that urgent problem of AI safety.
Now, inside Claude, the researchers did find features for a lot of dangerous concepts. Things like code backdoors or deceptive behaviors. But to be super clear, they didn't add these. They were already there. They simply identified the parts of the model that correspond to its existing knowledge of these dangerous topics. Here's another perfect example. They found a feature for sycophancy, basically being a brown-noser. So when a user falsely claimed they invented a famous phrase, Claude would normally correct them gently. But by activating that sycophancy feature, they made it lie and just flatter the user, saying things like, "Your wisdom is unquestionable."
And that, right there, is the whole point. Finding these dangerous features isn't about exploiting them. It's about finally having a lever we can pull, a handle we can grab onto. It's a way to monitor, to control, and to build real guardrails against these behaviors, making the AI safer from the inside out.
I mean, the possibilities this opens up for safety are huge. We could potentially monitor an AI for deceptive thinking in real time. We could actively steer it away from biased outputs, maybe even perform a kind of surgery to remove dangerous knowledge, like how to develop a bioweapon. It's a way to find those hidden vulnerabilities before they cause real harm.
But okay, let's pump the brakes just a little. We have to be clear. This work has just begun. These millions of features, as incredible as they are, still only represent a small piece of everything Claude knows. We might have the dictionary now, but we still need to figure out the grammar, the circuits that combine all these words into complex thoughts.
This research really is a pivotal moment. It changes our relationship with AI and brings us to a profound and, honestly, a pretty hopeful final question. If we can truly map the mind of an AI,
Can we finally teach it how to be safe? By actually understanding its thoughts, can we finally align its internal world with our values? That's the challenge, but it's also the incredible promise that lies